Hello everyone, welcome back to my channel. Today we're going to be taking a look at an SAT question. Points P, Q, R, and S are in a circle, and a diameter of the circle is PQ, which has length 145. Segments RS and PQ are perpendicular and intersect at point T. The length of RT is root 286. If PT is greater than QT, what is the ratio of PT to QT? So I'll just sketch what they're telling us is going on. So we have a circle and a diameter PQ, and it's going to pass through the center of the circle. Let's call it O. And it's saying it's saying this length is 145, so PQ is 145. By the way, I also like to use this notation where you have the absolute value signs, but for this we'll just use the line at the top. So it says that there's a segment RS that is perpendicular to PQ on the circle. So we don't know if this segment RS is passing through the center of the circle, in which it would be a diameter of the circle. But in the end, it states that PT is greater than QT after RT intersects PQ. So if PT is greater than QT, then PT in the line must actually intersect lower than the center of the circle. So because this intersects at T, call this R, call this S. And the question says that PT length is greater than the length of QT. This is what the question is asking, or it's stating. And it says that RT is root 286. And what do we know about lines that pass through diameters perpendicularly? It's that this is actually a perpendicular bisector. So this means that the length of RT is the same length as TS. So if you have a circle, any kind of line that passes perpendicular to the circle will always have the same length on either side. I did that wrong. So that's just something you have to know. So that means that this is also root 286. So it's saying if PT is greater than QT, what is the ratio of PT to QT? So how do we get the length of PT versus the length of QT? Well, notice that PT is just the radius of the circle plus this length OT. And QT is the radius minus the length OT. So we can make a quick equation. PT is equal to radius. We know that the diameter is 148, so the radius is diameter divided by 2, 72.5. So it's going to be 72.5 plus, we have 72.5 here, plus this OT. And then we have that QT is the radius 72.5 minus OT. Now we have two equations, but we have three unknowns. We have OT, PT, and QT. So if we just find OT, we can find PT, and we can find QT based on how these equations are set up. So to find OT, what's something we can do? Well, what do we notice about the radii that you can construct on the circle? This is a radius. This is a radius. It's red here. This is also a radius. Similarly, this is also a radius, but we don't have to worry about that. So we know that this is a radius. And if this is 72.5, then this must also be 72.5 because radii are always equal to each other. So this is also 72.5. Now, because it intersects at a 90, what do we notice about this triangle here? We can find OT given the hypotenuse and this leg. So OT is equal to the root of 72.5 squared minus root 286 squared. And this comes out to, well, this is 286, right? And I believe this, oh, we have to use a calculator. Thought I had the answers memorized. 72.5 squared minus 286. Root that, and you get 70.5. So this is 72.5, or 70.5. We have OT, we can get PT, get QT, divide them, and we have a ratio. So PT over QT is equal to 72.5 plus OT, which is this 70.5, over 72.5 minus 70.5, which is equal to 143 over 2, which is 71.5. So our answer is B. And now for question 17. The linear function g is defined by g at x is ax plus 5. The graph of y equals g at x in the xy plane has its y-intercept at 0, c, and its x-intercept at d, 0, where c and d are positive constants. What is the value of c plus d in terms of a? So it says we have g at x equals ax plus 5. And it's saying there's a point that's the y-intercept at 0, c. So if we sub in 0, c into this, into g, we get that c is equal to a times x is going to be 0 plus 5, because it's the y-intercept of g at x. So then we get that c equals 5. You don't really have to do this if you know that the final term in the form y equals mx plus b. If you know that this term, this b term, is actually the same thing, you don't really have to go through this process of subbing in 0, c. You just know that b is going to be the 5. So that's a fast way to know if what your c value is for this question. So we have that c is equal to 5. And then we're going to sub in the x-intercept, d, 0. So then sub in d, 0. Then you get 0 is equal to a times d plus 5. And we're going to isolate for d because we want d in terms of a. So d is equal to -5 over a. And it's saying what is c plus d? Well, c plus d, well, that's 5 because we have that c is 5. And d is going to be -5 over a. And we would need a common denominator in the question. So we get 5a minus 5 over a. So answer is going to be A.